For this problem, we need to redraw our circuit in the frequency domain and find the Laplace form of the voltage V naught t, and then also find V of s. So to do this, let's look at our source current. We're given source current instead of source voltage like other problems. And so our source current is I of g is equal to 5 milliamps for t greater than or equal to 0. And that's what we're going to be looking at. So we can rewrite our I of g. And remember, whenever we want to convert our source to the s domain, we're going to put it over s. So we're going to have Ig over s, and this is equal to 5 times 10 to the negative cubed divided by s. And so that is our source. Now we're going to use node voltage method, and we can look at the node going into this node. And so the current actually going into this node is coming from our source. So our source current is going into this node. Some of our current is going to make its way down here. Some of its current is going to make its way down here, and then some of our current is going to make its way down here. Now, since we don't have any kind of resistance up here, we can just add both of these together in the same node voltage equation and not make a second one. So looking at this, we are going to have to convert some things. This V, I think, phase is going to be V of s. So we have V of s here. This V naught is going to be V naught s. And this is going to have an s after it as well. Once we have this, we are going to have to convert this capacitor. We have Z of C is equal to 1 over S of C. And if we plug this into a calculator, we are going to get 4 times 10 to the 6th divided by S. Now, we need to convert this inductor. So to convert the inductor, we're going to have Z of L is equal to S of L, and this is equal to S times 40 times 10 to the negative cubed. And that is the conversion. Now we can start writing our node voltage method. We have some current going into our node, and if we have current going into our node, it's negative, so we can write our source as negative 5 times 10 to the negative 3 divided by our S. Then we have our voltage over this entire part, and the voltage over this entire part is not this V phase right here. It's actually this V naught S, and that's because this line is in parallel with this line. And so we can write this as plus V naught S minus. And we know two things in parallel with each other have the same voltage. So we are going to have a V naught S, and this is all over the impedance of that line. So we're going to have 200 plus 4 times 10 to the 6th divided by S. So we have all the impedances together. Next we're going to look at this V naught S right here. And looking at this, we're going to have a plus 3.75 times 10 to the negative 3, and then we have this V phase S in here. Next we have the voltage over this inductor, and so, or the current over the inductor, and this is going to be plus. We can see that this V naught is also in parallel with this inductor, so we're going to have a plus minus V naught over here. And so that means we are going to have a V naught over the inductor, which is 40 times 10 to the negative 3 S. And this is all equal to 0. And so this is going to be our equation. We have one unknown right here, and we can solve for it given all of this information right here. So in solving for this, we'll do it in blue. We are going to have a V naught, and this V naught, well, it's this entire part, right? So it's the total voltage of this line over the total impedance of this line. So V naught is divided by 200 plus 4 times 10 to the 6th divided by S. And well, we're going to say that if we subtract this V phase, so this V phase is going to be the V phase of S over the impedance, which is 4 times 10 to the 6th of S. It is equal to 0. And we're not subtracting voltages here. What we have is some voltage over some impedance, which is like voltage over resistance, which using Ohm's law is current. So voltage over resistance is current. So we are finding current here. And we're saying that the total current minus this current of the capacitor is going to be equal to 0. And so we can rewrite this and simplify some things. We are going to have v naught, and we're going to basically just move this over to this side. And after we move it over to the right hand side, what we can do is we can multiply everything by 4 times 10 to the 6 divided by s. And if we do this, we are going to get our v naught here. And then our v naught is going to have this 4 times 10 to the 6 divided by s over our 200 plus 4 times 6x, or 4 times 10 to the 6 over s, and this is equal to our v phase s. And so this is going to be our equation minus this really poorly written 200. We are going to have this for our v phase of s. And so what we can do is just plug it into our v phase s right here, and that means we'll have all v naught s. Also, I'm going to be moving this to the right hand side. So in doing this, we are going to get a 5 times 10 to the negative 3 divided by s. This is equal to, we can factor out our v naught s early, so we're going to have v naught s out here, and then inside we'll have these brackets because we'll have a lot inside of here. 1 divided by 200 plus 4 times 10 to the 6 divided by s. This is the first part right here. Now we're going to be dealing with this part. We'll have a plus 3.75 times 10 to the negative cubed, and then we have all of this inside of here. So we are going to multiply everything by 4 times 10 to the 6 divided by s, and then we're going to have 200 plus 4 times 10 to the 6 divided by s. And then we have this last part right here. And for this last part, we are going to have a plus 1 divided by 40 times 10 to the negative cubed s. And then we can close this off. And this is going to be our large but final part of the equation that we are going to be dealing with. So for here, there is a couple things that we can do. The first thing is we can combine these two together, and we'll make them all one numerator. And then after this, what we can do to get rid of the denominators on just the right side, we are going to multiply everything on the right by s over s. And we can do this because we're basically multiplying by 1, and since we're not technically changing anything, it's legal mathematically. So inside of here, we're still going to have our 5 times 10 to the negative cubed over s, and this is equal to, we have our v naught s still on the outside, and then in our brackets, if we have an s over s, well, we'll have an s up top, and this is being divided by, we'll have our 200 s plus 4 times 10 to the 6th. Plugging this next part into a calculator, we will have a plus a 15 times 10 cubed, and since we have this s up top, it's going to cancel with this s right here, so this is just going to be over 200 plus 4 times 10 to the 6th. And then for this last part, well, if we introduce an s in here, it's going to give us an s squared, and we'll just have an s on top. So this last part's not going to change, and it's just going to be 1 over 40 times 10 to the negative cubed s. And so this is going to be our new equation. Now from here, what we can do is combine like terms. We can see that these two have the same denominator, so we can easily do that. We're going to have a 5 times 10 to the negative cubed over s, and this is equal to our v naught s, and then inside of here we have the s plus 15 times 10 cubed, and this is divided by our 200 s plus 4 times 10 to the 6th plus the 1 over 40 times 10 to the negative cubed s. So knowing this, well, we can combine these two together now. And to combine these two, to find the common denominator, we're just going to multiply this across. We're going to multiply this across. We're going to add the two numerators, the new numerators together, and then we are going to multiply the denominators together. So for this, we have 5 times 10 to the negative cubed over s is equal to our v naught s. And then inside of here, well, we have this 40 times 10 to the negative cubed s, first times this s. So we're going to have a 40 times 10 negative cubed s squared. Then we have this 15 times 10 cubed times this 40 times 10 to the negative cubed s. And the 10 cube and the negative 10 cube are going to cancel out. We are then just going to have a plus 600s. And then we will have a plus, because all of this is being multiplied across here, 200s plus 4 times 10 to the 6th. And then this is divided all by 200s plus 4 times 10 to the 6th. And then 40 times 10 to the negative cubed s. And so this is going to be our new equation. I'm going to move it a little bit because it's a little bit hard to see right underneath the previous one. So it's going to look like this. And this is what we have so far. From here, it becomes a little bit easier to see what we need to do. From here, we need to get the v naught s by itself. So we're basically going to take the inverse of this, and we're going to multiply it on the other side. But before we do that, just to make things a little bit easier, we can combine these two denominators. And before we combine the two denominators, we can cancel out this s, because we have an s on the bottom that'll be multiplied throughout everything. So we can cancel those out, and then just combine these two. In combining these two, we're going to get an 8s plus 16 plus 160 times 10 to the 6th times 10 to the cubed. And so this is going to be the answer for this part. We're now going to multiply this on both sides. And on multiplying this to both sides, we are going to get a 40 times 10 to the negative cubed times s plus 800. And so this is going to be the numerator for this new part that we have. And then from here, we're going to take this numerator, and then actually, before we take this numerator, we can combine these two, and this will give us an 800s. And now we can take the numerator and then divide it by both sides, and that way we can get this in the denominator here as 40 times 10 to the negative cubed s squared plus 800s plus 4 times 10 to the 6th. And this is all equal to our v naught s. Now, we just need to find for our v naught s. What we can do is we can simplify this further. We can take this 40 times 10 to the negative cubed and take it out from the denominator. We can factor it out from both the numerator and the denominator. So inside of here, we're going to have an s plus, and we're basically going to take our 800 and divide it by the 40 times 10 to the negative cubed to factor it out. This will give us an s plus 20 times 10 to the cubed. And then we can divide this by, we are going to have an s squared here. We are going to have another plus 20 times 10 cubed here. And then lastly, we need to take our 4 times 10 to the 6th and also divide it by 40 times 10 to the negative cubed. And this is going to give us a pretty big number. And instead of writing it out like that, we can just write it as plus 100 times 10 to the 6th. And this is all equal to our v naught of s. Now, we can see that these two are going to cancel out, and we are left with a much smaller equation. From here, we can actually simplify a little bit further. If we take our denominator, and I've substituted, this should also have an s in it. I don't know why I left that out. It should have an s because we have an s right here. We can take this and we can plug it into a calculator. I'm using a symbol lab here. We have x squared plus 20,000x plus all this, which is the 100 times 10 to the 6th. And this is going to give us an x plus 10,000 squared. And so we can go ahead and rewrite this as s plus 20, and I'll actually write it a line below, that way it's a little bit clearer. S plus 20 times 10 to the cubed divided by s plus 10,000 squared. And this is equal to our v naught s. And using differential equations, we can say, well, this is equal to a over our s plus 10,000 plus our b over s plus 10,000, and this is squared. Now we could use the Heaviside cover-up, but I'm just going to completely write this out because it's pretty big. So, or it's pretty weird for the Heaviside cover-up. So what I'm going to do is I'm going to multiply both sides by this. And so we're going to be left with an s plus 20 times 10 cubed equal to an a s plus 10,000 plus b. And so this is going to be our new equation. And from here, what we're going to do is we're going to say, okay, well, if we make s equal to a negative 10,000, and we make s equal to a negative 10,000 on this side, this is going to give us a 10,000, because we have 20,000 minus 10,000, that gives us 10,000 here. And then our right side, and we'll just rewrite this totally, is equal to 0 plus b. So that means b is equal to 10,000. Now we can solve for our a. We'll say that s plus 20 times 10 cubed is equal to our a, s plus 10,000 plus 10,000 for our b. We're plugging in our b here. Now, what we can do is just plug in any number for our s's. I'm going to just plug in 0. So we plug in 0 here. And now we can subtract this 10,000 from both sides. We have 20,000 minus 10,000. This is going to give us 10,000 equal to an a times our 10,000. And so our a is equal to 1. And now that our a is equal to 1, what we can do is plug our a and b back into this equation. So plugging it back in, we have a 1 over s plus 10, and I'll just write this as 10k, plus 10k divided by s plus 10k. And this is squared. So there's a slight difference here. Now if we look at the notes linked below the like button, page 50, we have this table right here. And this table says that, and I'll just write this in green to the right, we have a e negative at equal to a 1 over s plus a. And then we also have a t e negative at equal to a 1 over s plus a squared. And if we look at our equation, this is exactly what we have. So we can rewrite this in the time domain because we're currently still in the s domain. Which reminds me, we've solved for our a already. And we've solved for our a in this step, where we have this v naught s equal to the simplified version right here. So this is going to be the answer for part A. And if we write this in here, we have s plus, we have, or 20,000, and then we have this divided by s plus, and then 10,000 in here. And so that is the answer for the first part. Now we're going to move on to the second part B, which we are solving for now. So now we are going to look at these and convert it into the time domain. So this first part is going to be the first screen equation. We have a e to the negative 10k, or negative 10,000, and this is being multiplied by t. We have a plus, we have a t times our e, and we have this 10k out here that we don't have in the numerator here, right here. So what we can do is just multiply this as 10,000 out front times e negative, we have this 10,000 in our a slot, so 10,000 up here. And this is being multiplied by t. And this is our equation. However, we're not done. We are in the time domain, so we're going to have to multiply this by our u of t. And so scrolling back up to the answer, we can write this as, well, we're going to write the first part right here. That's this part. We have it in brackets, and our u of t is outside. We have 10,000 here, and then we have to the exponent, well, our exponent's negative 10,000, so negative 10, 1, 2, 3,000, plus the exponent, this negative 10,000, so negative 10,000. Also, I don't think that means exponent, I'm pretty sure it just means this e right here. And we've solved the problem. And that's all the work we've done. We've gone through this step first, finding the node voltage method, looking at our circuit. We've simplified it all really throughout here. We also substituted this V phase S into here to solve for it. Simplified it a little bit further right here, and then we started doing part B around this area. And so that is how you would solve for this problem.